Three particles are located at each vertex of an equilateral triangle ABC of side length A. Each particle starts moving towards each other. That is, the first particle starts moving towards the second towards the third, and the third towards the first. Each particle is moving with a uniform velocity v, and their direction of motion is always towards its respective target particle. Now the question is, in how much time will elapse and what distance do the particles cover before they meet, and what will be the equation for their paths. So at t equal to 0, particle was at the points A, B and C respectively. Now after a certain time t, their position will be at these points. And at this position also, their direction of motion is always towards its target particle. So if you keep moving like this, then you will find the particles follow a spiral path. And they will meet with each other at the centroid of the triangle. Now to find the time elapsed and distance traveled during this motion, let's start with the initial configuration of the particles. Let us focus on the particle at point A. It is moving towards B with velocity v. Now its velocity can be resolved into two perpendicular components. One is along the horizontal direction and the another is along the vertical direction. The horizontal component of the velocity will be directed towards the particles at C. Now the velocity vector makes an angle 60 degree with the horizontal component as the triangle is equilateral. Therefore, the horizontal component of the velocity will be Vh equals to V cos 60 degree. Now cos 60 degree is half, therefore Vh is equals to V over 2. So you can say that the particle at point A is moving towards C with a velocity V over 2. And the vertical component will be V vertical is equals to V sin 60 degree, which is equals to root 3V over 2. Now as you can see, initially the particle at point C was also moving towards the particle at point A with a velocity V. So the relative velocity of the particles at point A and at point C is Vac equals to V plus V over 2, or it is equals to 3V over 2. Now this is also the relative velocity between the particles AC and BC. So the relative velocity between any two particles is same and it is 3V over 2. Now initially the particles are separated by a distance A and the final separation is 0. That is when the particles meet with each other at the centroid of the triangle. Therefore time taken in this process will be t equals to 0 minus a over the relative velocity, or this is equals to 2a over 3v. So time depends on the length of the triangle and it is inversely proportional to the velocity of the particles. Now the distance covered by each particle will be d equals to velocity into time, which is equals to v times 2a over 3v, and this is equals to 2a over 3. Therefore after a time 2a over 3v, and after traveling a distance of 2a over 3, the particles will meet with each other at the centroid of the triangle. Now we need to find the equation for the trajectory of their motion. It will be easy to find the equation if we use the polar coordinate system. Let O be the origin and initially the position of the particle is at C and its position is represented by the position vector r. Therefore the angle between the position vector r and the velocity vector v is 5 pi over 6. Now let after a time t, the position of the particle is at C prime and it makes an angle theta with the initial position vector, or you can say that both theta and the position vector r are both changing with time. Now initially when time is 0, that is t equals to 0, the particle is located at r equals to a over root 3 and theta is equals to 0 degree. So you can say these are the initial conditions for our problem. Now in polar coordinate system, the velocity vector is given by v equals to r dot r cap plus r theta dot theta cap, or this can be written as vr r cap plus v theta theta cap. So vr represents the radial part of the velocity and v theta represents the angular part of the velocity. Therefore, the ratio v theta over vr is equals to tan 5 pi by 6, or this is equals to minus 1 over square root of 3, and again this can be written as r theta dot over r dot. Therefore, we have r theta dot is equals to minus r dot over square root of 3. Now from the expression of the velocity vector, we can write v square is equals to r dot square plus r square theta dot square. Now if we use the relation r theta dot is equals to minus r dot root 3, then we will get v square is equals to r dot square plus r dot square over v, or this is equals to 4 r dot square over v. Therefore, v is equals to plus minus 2 r dot over root 3. But as time increased, radial vector r decreases. So we have to consider the negative part of the velocity. Therefore, v is minus 2 r dot over root 3, or r dot is equals to minus root 3v over 2. Now, if you integrate it over time, then you will have r as a function of t equals to root 3v over 2 times t plus c. Here, c is the integration constant. Now, using the initial condition for the particle, we can evaluate c. So, if we use the initial condition that at t equals to 0, r is equals to a over root 3, then we can write r of 0 is equals to minus root 3v over 2 times 0 plus c, or c is equals to a over root 3. Now, if we put c in the expression of r of t, then we can write r of t is equals to a over square root of 3 minus square root of 3vt over 2. Now at origin, that is at point O, the value of the radius vector is 0. Therefore, we can write 0 equals to a over root 3 minus root 3v over 2 times t. And from this, we can evaluate t, which is t is equals to 2a over 3v. This is the same value of t as we got earlier, that is the time required to meet all the particles at the centroid of the triangle or at point O. Now to find the equation for theta, let's start with this expression. That is r theta dot is equals to minus r dot over square root of 3, or this can be written as r dot equals to minus square root of 3 r theta dot. Now if we replace this in the expression v squared equals to r dot square plus r square theta dot square, then we will have v squared is equals to 4r square theta dot square, or we can write theta dot is equals to v over 2r. Now in this expression of theta dot, if we replace r, then theta dot will be root 3v over 2a minus 3vt. Now again integrating both sides, we will have theta is equals to minus 1 over root 3 log of 2a minus 3vt plus c prime. Here c prime is an integration constant and we have to evaluate it using the initial conditions. So at t equals to 0, theta is 0 degree, and using this initial condition, c prime will be 1 over root 3 log of 2a. Now if we replace this, then theta will be minus 1 over root 3 log of 2a minus 3vt over 2a, or this can be written as r is equals to square root of 3 over a times e to the power minus root 3 theta. So this is the equation for the trajectory of the particle, and this equation is also known as logarithmic spiral, and it implies that the radius vector r will be 0 after turning through an infinite angle. Therefore, we can say that a point-like body reaches the center in finite time and after traveling a finite distance but only making infinite rotations about the center.